Hello and welcome. Welcome to a new world full of signals and systems. Let us begin our journey in this new world. What is a signal? Signal is nothing but another name of functions of time. You are definitely familiar with the concept of a function, like you may write x equal to f of t, some function of time, or y equal to some other function of time gt, where this alphabet t stands for time. Such functions which depend on time are called signals. So signal is synonymous to function of time. Now such functions or any function can be drawn like a graph. Time versus amplitude. Let me draw some arbitrary function which looks like this. Call this function x of t, and let us define a new function, say x to t, which is defined to be 2 times x of t. Let me now ask, how will this graph look like? It will look very similar to xt, except that its height will be doubled at each and every instant of time. For example, here the height is 0, so it will remain 0. Here the height is 1, so it will become 2. Here the height is 3, so it will become 6. Here it will become 2. Here it will become -4, and so on. Now you may join all these points together . And this is how x to t will look like. So this is x to t equals 2xt, and this is xt. Similarly, you may define another graph, call it x half t, which is same as half times xt. And how will that look like? Very similar to the original curve, but its height will be halved at each and every instant of time, and thus it looks somewhat like this. This is our x half t. In general, you can define any other function, call it yt is equal to some constant k times x of t. K can be less than or greater than or equal to 1. This process is called amplitude scaling. Where the amplitude of the signal is multiplied by a constant scale factor k. Let us now learn something new, which we will call time scaling. Suppose I take a function xt which looks like this. Let me give this coordinate point some name A, B, C, D, E, F, G, H, and this is t equal to 1, or let me take this as t equal to 1, this as t equal to 2, then t equal to 3, 4. This is the origin, time equal to 0, here -1 and here -2. Now let me define a new function yt is equal to x of 2t, and I ask how will this function look like. Let us find that out. So we are going to plot yt, which is defined to be x of 2t. This is time axis. This is t equal to 0, 1, 2, 3, 4. Here -1, -2, -3, -1, -2 and -3 and so on. Now we will ask what should be the value of y0. Now y0 is equal to x 2 times 0, which is same as x0, and the value of x0 is here, it is 1. So we put 1 here. Then we ask the value of y at t equal to 1, which is same as x of 2 into 1, same as x of 2, and that is 0. So we put 0 here. Similarly, y of 2 will be same as x of 2 into 2, which is x of 4, and x of 4 is -1. So here we will put -1. We need more points. We need y half, for example. Y half is same as x2 into half, which is x1, and the value of x1 is 2. So here the value will be 2. Similarly, you calculate the value of y at 1.5. That will be same as x3, and x3 is -1. So x3 will come here, that is this point. Now let us join these points. Similarly, on the left side, the curve will look like this. This will be point B, this is point A, this is point D, point C is here, point E, point F, G and H. So you observe that x2t is squeezed, is compressed by a factor of half, because we have multiplied t with a factor of 2. Therefore x2t is compressed horizontally, that means along the time axis, by a factor of half, and this process is called time scaling. Similarly, you may guess now that if I define x3t equal to x of 3t, that will be compressed by a factor of 1/3. If you define, say, x of half t, which is x half of t, that will be expanded by a factor of 2. If this is half here, then the reciprocal is 2. Please verify this statement. That is your homework. Okay, now let us learn something new, and this is called time shifting. Suppose some function xt is already given to us. Let me copy our previous function. And now let us define a new function, say yt is equal to x t minus 1. How will this look like? Let us find that. time axis, and now we are going to find x t minus 1, which is same as yt. Yt is same as xt minus 1. Okay, so let us ask what will be the value of y at t equal to 0. So this will be given by y 0 minus 1, sorry, x of 0 minus 1 from here. y0 is x 0 minus 1. This is equal to x minus 1 and x minus 1, x minus 1 is somewhat near minus 1. So let me mark that point. It will be like this. Sorry, x minus 1 is here, minus 2. So it will be like this. Then y of 1 will be x of 1 minus 1 equal to x of 0, and x0 is 1, so y1 will be 1. Then 2, 3, 4, here on this side minus 1, minus 2, minus 3. We have to find the value of y at these points. So let's find y2. y2 is x of 2 minus 1, that is x of 1, and x of 1 is this point E, which is 2. Okay, so x2 is 2. Similarly, y3 will be x of 2, x of 2 is 0, so we mark this point, and then you can keep going. So let us write here y minus 1, that will be same as x of minus 1 equal to x of minus 2, and x of minus 2 is 0, so we put a 0 here, and let us now join all these points. Okay. If we go further, y of 4, that will be same. Let me write it here. Y of 4, that will be same as x of 3, and x3 is minus 1, so this point. Similarly, y5 will be same as x4, which is this point. Now let us join these points also, and this is how the graph is going to look like. If I label these points as A, B, C, D, E, F, G and H, you can clearly see that this graph is shifted towards the right by 1 unit. Okay, point B was at -1, now point B is at 0. So observe yt is shifted 1 unit towards right. Okay. Similarly, you should verify this yourself, that if I define another function, say zt equals x of t minus 2, that will be shifted towards right by 2 units of time. If I define zt equals x of t minus some constant, call it tau, some constant number, then that will be shifted towards the right by tau units of time. Similarly, if you define zt equals x t plus tau, and if tau is a positive number, then that signal will be shifted towards the left in the opposite direction by tau units. Please verify these conclusions yourself. Let us now learn a new concept, which is time reversal. For that, we will again start with a given function. Let me copy this from our previous page. And now let us define yt is equal to x of minus t, and let us ask how will the graph look like. So let us try. Time axis versus amplitude, t versus yt equals x of minus t. What will be the value of y at t equal to 0? That is going to be x of minus 0 same as x of 0. And x of 0 is 1, so that point will be here. This is t equal to 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, so on, minus 4. Now y of 1, that will be same as x of minus 1, and x minus 1 is equal to minus 2, so we put minus 2 here. y2 is same as x of minus 2, which is 0, so we put 0 here. Y of minus 1, that will be same as x of minus 1, which is same as x of 1, and x1 is 2, so here we will put 2. If you continue like that, y of minus 2 will be same as x of plus 2, y of minus 3 and y of minus 4, they will be same as x of 3 and x of 4, respectively. Now x3 is minus 1, so here we will put minus 1, and x4 is also minus 1, okay, and to get the value here, x2 is 0, okay. So these are the points. Now let us join them like this. Okay, and now let me mark these points as A, B, D, this is C, E, F, G and H. Now you observe that this graph is horizontally flipped, okay, and flipped around this, about this vertical axis or t equal to 0 axis. So you observe that the graph that yt is horizontally flipped. Okay, and please note that the point which is on the vertical axis, that remains unchanged. That position does not change. This is called time reversal. So we have learned about amplitude scaling, time scaling, time reversal and time shifting. Now let us see one example in which all of these act together, all of these are applied together. Okay, let us solve one example problem. So here is the example. Some arbitrary graph xt is given to us, which is piecewise linear, only for the simplicity of demonstration. In general, it can be any smooth, continuous or any arbitrary curve. Okay? And the question is, plot the function yt, which is defined as, say, minus 2x then minus 2t plus 3. That's the question. We shall solve this question in a number of steps, and the steps are like this. So you start with the graph of x0, which is given, already given. Then the first step is to draw x of, this is xt. xt is given. Now you draw x of t plus 3. Then you draw two t plus 3, then x minus 2t plus 3, then 2x minus 2t plus 3, and finally minus 2x minus 2t plus 3. We shall start with this and plot these graphs one by one. Let us see. Okay, so let me copy this graph. This is the original graph which is given, and then step 1 is to draw x t plus 3. So that means t here is being replaced by t plus 3. Time versus amplitude. We are going to plot x of t plus 3, and this is going to cause a time shift. So this graph will shift 3 units towards the left because this is positive. So this point D will come 1, 2, 3 here. So let me mark. Point D will come 1, 2, 3 here. Then point E will be here. This is D. This is E. Then point F will be here. Point F was originally at t equal to 4 and now it is at t equal to 1. Okay, because shifted towards the left by 3 units. Point G will be here. This is G. Similarly, point C, point B and point A here. Let me join these points. So you can clearly see that this graph and this graph are very much similar, except that it is moved towards the left by 3 units. That was step 1. Now we shall move to step 2. For that, let me copy this graph. And here we start step 2 to find x 2t plus 3. We are going to find x 2t plus 3. Note that here we have t plus 3 and here 2t plus 3, which means t is being replaced by 2t. Okay, the variable t, this alphabet t, is replaced by 2t. So this graph will be squeezed, compressed, that is time scaling, and while this graph is compressed, the point which is on the vertical axis, that will not move. So if I call this point x, x will remain at this point, but all other points will move. Point F will come closer to the vertical axis here. Point G, which is at 3 units distance from vertical axis, will be now at a distance of 1.5. Point E will be here. Point D will be here. Point C will be here. Point B, which is at 1, 2, 3, 4, 5, 6, 7 at t equal to -7 will now be at t equal to -3.5. So 1, 2, 3 and half. So point B will be here. Point A will be here at a distance of 1, 2, 3, 4, 4.5. Because here it is at a distance of 9. Let me now join these points. And this is how this curve will look like. Our step 2 is complete. Now let's move to step 3. This is the result of step 2, and now we will draw x of -2t plus 3. This is step 3. So you see that here we have 2t and here -2t, which means t is replaced by -t. Okay, so x -2t plus 3 versus time. Since this t is replaced by -t, this graph will flip horizontally about the y-axis. Okay, so this will be flipped horizontally, and the point, this yellow point which is on this vertical axis, will not change its position. So this point x will remain here. Point F will come on the left side. Point E will go to the right side. Sorry, it is here. Point D here. Point C here. B here and A here. Point G on the left side. Let me join these points. And that's how x -2t plus 3 is going to look like. Our step 3 is complete. So let me move to next page and proceed for step 4, where we shall now find minus 2t plus 3. Time versus 2x minus 2t plus 3. So the amplitude is going to be scaled by a factor of 2. This point F, which is at a height of 3 units, will now move at a height of 1, 2, 3, 4, 5 and 6. Here will be F. Point E will be here at a height of 2. Point D, which is at a height of 1, will go to height 2. Point C will now be at a height of minus 2. Point B minus 2. Point A will remain at 0 because 2 times 0 is 0. Similarly, point G will remain at 0. Now join these points. This is the result of step 4. Step 4 is complete. We will move to the next page. This is the result of step 4, and we shall start step number 5, where we will multiply this signal with a minus sign, 2x minus 2t plus 3. Okay, so this will cause the signal to flip vertically because of this minus sign. Point F, which is at plus 6 height, will now come to 1, 2, 3, 4, 5, 6, minus 6. Point E will go to minus 2. D, this is F, this was G. G will remain as it is. C will become positive. B will become positive, and this was point A, that will remain as it is. A, C and B. Let me join. So I join these lines, these points, and you can see that this graph here, it is vertically flipped. So this is the final result. This is same as yt. Yt is minus 2x minus 2t plus 3. Okay, so we got our answer, but we should verify our answer so that we do not make any mistake. So let us do the verification. So we know that yt is given as minus 2x minus 2t plus 3. That means if I ask, say, what is the value of y at t equal to minus half? T equal to minus half, this is this point. At this point, what is the value of y? Y minus half, this should be equal to minus 2x, here 2 into minus half plus 3. Okay, and this is same as minus 2x, inside it will be 1 plus 3 equal to 4. So the value of x4 will determine the value of y at this point. So let us go back to the original curve and find the value of x4. Here is the original curve, and x4 is equal to 3, and this point you see is labeled as F. So x4 is 3. So this is equal to minus 2 into 3, which is same as minus 6. So the value or the height amplitude here should be minus 6. 1, 2, 3, 4, 5, 6. Yes. So we are correct. And you also see that this point is labeled as F. So this verification tells that we did not make any mistake in this calculation. So this seems correct. You should do this verification for a few more points, like what should be the value at say t equals 2.5, and check the value whether it is same as 2 or not. Okay. Now let me just go back. So we have followed these steps. Okay, we started from the original graph, then we applied this is called time shifting, where t is replaced by t plus 3. Okay, t is becoming t plus 3. So from here to here we make t as t plus 3. Then from here to here we make t as, what is happening to t? T is becoming 2t. Always note what is happening to this alphabet t, to this variable t. That is the key point. Okay. Then similarly here to here t is becoming minus t. This is time scaling. This is time reversal. And we have followed this order: shifting, then scaling, then reversal. Okay, and then amplitude scaling, and so on. You may remember this order of steps, although that is not necessary. If you carefully note what you are doing to this variable t, you do not need to remember, but you may remember this order so that you do not make a mistake. Now the thing that we shall learn today is about odd and even signals or odd and even functions. Okay. So a function is called even if x of t is equal to x of minus t. An example of such function, very common function, is cosine t. A cosine function will look like this. This is time versus cosine t, and you see that the value at some time is same as the value at the negative of minus of that time. X of t is same as minus xt for cosine t, because cosine minus t is same as cosine t. So such graphs look symmetric with respect to the vertical axis or t equal to 0 axis. Similarly, a function is called an odd function or an odd signal if x of t is same as minus x of minus t. One popular example is, of course, sine t. And you know that sine of minus t is same as minus sine t, and a sine curve looks like this. And here you see that this function is symmetric but in a peculiar way. You can call it anti-symmetric with respect to the time equal to 0 axis or the vertical axis. Okay. Now you can have signals which are neither even nor odd. So we may have signals which are neither even or nor odd. For example, consider xt equal to e to the power t. So if we plot this graph, at t equal to 0, xt will be 1, and then it will increase exponentially. On the other hand, it will decrease and asymptotically go towards the 0. So that's how the graph of e to the power t looks like, and you see it is neither even nor odd. If you flip this signal around the vertical axis, it will not remain symmetric or neither antisymmetric. But the very important thing that we will learn is this fact, that any signal can be broken into a even and a odd signal. Any signal can be written as the sum of an even and an odd signal. So this is the statement, very important statement, that any arbitrary signal can be written or expressed as the sum of an even signal and an odd signal. It's a very useful theorem, you may call. Suppose some signal xt is given, which is neither odd nor even. We can always write this xt as xt plus x minus t plus xt minus x minus t. So that this this extra term cancels, but now I have xt twice, so let me divide everything by a factor of 2 and a factor of 2. Okay, you verify that the right hand side is same as the left hand side, xt. Now let me call this part as x even t. This is a function of time, and I am giving this function the name x even. Similarly, I am giving this function a name x of odd t. Okay. Now you can verify that this function x even is a even function. Okay, let's verify. So I am claiming that this is an even function or even signal, and this is an odd signal. Let us verify. So to verify, what we will do, we will find the value of x even at minus t. Okay, what is this? Let me first write that x even t is same as xt plus x minus t whole divided by 2. This is as per the definition, as I have defined, as I have named it. Okay, so therefore x even minus t will be equal to, in this expression now I have to replace all this t by minus t, so this t will become minus t and plus this minus t will become plus t whole divided by 2. And you see that this is same as this. This is same as x even t. Therefore, x even minus t is same as x even plus t. And thereby this function is a even function. Okay. Similarly, on this side, let me start with the definition of x odd t, which is this: xt minus x minus t whole divided by 2. And now I will put x odd minus t. Okay, let me put the t here. This was x odd t. Now I am putting minus t in place of t, so replace all t by minus t everywhere. So this becomes x minus t minus x plus t whole divided by 2. Now you compare this expression with this expression and you will see that this is same as minus x odd t. Okay, therefore x odd t is same as x odd minus t, and that proves that this part is an odd signal, odd function. Okay, therefore any signal, given any signal, odd or even or anything, can always be broken into odd and even as a sum of an even part, even component and a odd component. This is a very useful trick, useful theorem, useful result that you must remember. Okay, let us take an example. Suppose xt is given as e to the power jt, where j is the imaginary number root over minus 1, complex number. Okay, then I want to break it into as a sum of an even part and an odd part. So the even part will be x even will be xt plus x minus t whole divided by 2. Now if I put the values, this is same as e to the power jt plus e to the power minus jt whole divided by 2, and this is by definition, this is by the definition or by Taylor series expansion. You can prove that this is same as cosine t. Okay, similarly you can calculate x odd t, that will be xt minus x minus t whole divided by 2. Now if I put the values, e to the power jt plus e to the power minus jt whole divided by 2. I can multiply this with j and divide by the same term j. Then this part you should recognize is as sine of t multiplied by this factor j. Okay, therefore e to the power jt you should be aware of, this is equal to cosine t plus j into sine t. That's what we see here. Xt is sum of x even, which is cosine t. Cosine function is even function, and the odd part is the sine t. Sine is the odd function. Finally, today we shall talk about or define energy and power of a signal. So for that, you imagine that we have a piece of resistance with value equal to 1, and the current flowing through this resistance is IT, a function of time or a signal. Now for this situation, instantaneous power at any moment is given by the Joule's law, I T square R, and R is equal to 1, so multiplied by 1. Now therefore the total energy dissipated or associated with this signal IT can be written as integration of I square t, which is this, multiplied by dt from the maybe from minus infinity to plus infinity. That is throughout the time span we can imagine. Now this is the total energy, and therefore we can calculate average power which will be the total energy divided by the total time. Now in this case total time is infinite, so let me write it this way. Say starting from time minus t to time plus t, and then divide it with total time span 2t, and let this t tend to infinity in limit. So limit t tending to infinity 1 over 2t integration minus t to plus t I square dt is the average power consumed. Now keeping this in mind, we define the energy of a general signal general function of time xt as integration of x square t dt from minus infinity to plus infinity, and you may also write it this way, minus t2 plus t with limit t tending to infinity. This is the total energy. Now this x may be current or may be some other physical quantity, and therefore this energy might not be the energy that we study in physics. This may not be heat energy or any similar energy, but this is the definition of energy of any signal. It may be physically same as physical energy or may not be, doesn't matter. And similarly, the average power of a signal is defined as the total energy divided by total time. Okay, again this physically need not represent power in watt. Okay, but this is the mathematical definition of power of any signal or any function. Now consider a signal which spans for a short duration, maybe like this. After this point the signal is 0, before this point the signal is 0. Call it xt. Now if you calculate the energy that is integration of x square t dt from minus t to plus t with limit t tending to infinity, you will get some finite number. Essentially, you have to carry out this integration from this point to this point. After that or before that, the integration will result in 0. But if you calculate power of this signal, so you have to divide the energy by 2t, then you shall get 0 as you take larger and larger value of time. The total energy is going to remain same, but you are dividing with larger and larger value of time, so you will get smaller and smaller value of power. In the limit it will give you 0. So we define energy signal as the signals for which energy is finite but power is 0. Such signals are called energy signals. Now on the other hand, consider a signal, say, which is, for example, periodic and say that is sine omega t. So it continues on both the sides of starting from minus infinity to plus infinity. Suppose this is sine omega t. Then if you calculate energy, that means you have to do the integration from minus infinity to plus infinity x square t, that is sine square t dt, you will get infinite. As you take larger and larger value of time, your result of integration will be larger and larger. But if you calculate power, that is, let me write again, that is going to give you a finite number, because as the range of time increases, the total energy increases and proportionally the time also increases. So when you divide the total energy by time, you get a finite number. And you know that if it is sine omega t, in that case the result will come out to be 1 over 2. So in power signals to be signals for which energy is infinite but power is finite. Thank you. Have a nice day.